Alright, nerds, so let's start. So today we're going to talk about waves and the properties of these waves and how this makes them useful. Okay, so first off, a wave is how energy moves from position A to position B. Now, again, the particles, they don't necessarily move so much, but the energy gets from part A to part B. It can go either through a medium or radiation. So it can either go through a vacuum or by vibrating particles, depending on what we're talking about. So a wave oscillates. This means moves backwards and forwards in periods of, so repeating units of time. They can be like a longitudinal wave where they go backwards and forwards. They oscillate backwards and forwards along the direction of movement, or they can be a transverse wave like we have here, where the energy is going in that direction, but the particles oscillate up and down perpendicular to that. So here we see an example of it, and a very quick way, something worth noticing, is that this little red particle here, it doesn't move very far. This is a longitudinal wave. And you can see that it actually only moves as far as the initial push does down here, and that's all oscillation is. It moves backwards and forwards in that very small frame. So the particle has an average position. And here, if we draw a line, or if we draw a straight line, we'll try it for this one, we can see that the particle just moves up and down that line. It doesn't, while the energy, and that's in the wavelength here, moves across this way, the particle itself just moves up and down. So that's cool. Alright, so the properties of waves that we are interested in are the wavelength, frequency, period, amplitude, velocity, or the speed of the wave, which depends on the type of wave, obviously, and the crest and the trough. Now, to be fair, that is a measure of these two right here. Alright, so the wavelength is the distance between two identical points, and the easiest thing is, as the wave comes down this way, is to mark here and mark here where it's coming down again and measure that distance there, and we'll call that the wavelength. As the energy increases for a wavelength, as the energy increases, the wavelength decreases, and that's to do with Planck's equations, such as E equals H, what was that one there? V over lambda. And all you really need to know is that if, as the wavelength here goes down, so a smaller number, this number here will go up. And basically, so as energy increases, wavelength decreases, or as wavelength increases, the energy decreases. So it's a measure of the wave. The symbol is lambda, and the unit is the meter. Now, you don't need to remember this, but you do need to know this formula here. Alright, so let's get on to frequency. So we could use this formula here to work out the frequency, and basically the frequency is the number of waves that go past a point. So if we go point A there, so the number of complete waves that go past that point every second or per second, the symbol is F, so that's the symbol we put into our equation down here, and the unit is hertz, or cycles per second. Amplitude is the height of the wave from the midpoint. Both the crest and the trough. Now, they don't get added together from here to here. It is this distance to that distance, and you'll see that this one here is just the negative of that. So, and they are a measure of the intensity or power. And what this means is, as the amplitude of a sound wave increases, the louder the sound. As the amplitude of a light wave increases, the brighter the light. So it's the distance between the crest and the midline, or the trough and the midline. The four properties of waves that we look at as well. There's reflection, refraction, diffraction, and absorption. So I want you to tabulate these from your textbook, page 124, but we'll just have a quick look at these now and what they do. So reflection is, again, when a wave, in this case it's a sound wave, bounces off, or in this case it bounces up and this way. Refraction is the bending of a wave as it travels from one medium to another. So this here would be water, and you can see that as it travels, so it's going through air into water or glass, which is more dense, and that means the light wave then starts to bends down that way, and that changes it. So that's also pretty cool. There's diffraction, where it starts to bend as it goes through an opening or over a mountain. If we've got a little mountain here and radio waves go past it, some will bend around to fill up that gap, and that's diffraction. And then we've got absorption, where as it travels through a medium, you can see that the intensity of the wave, it decreases. The wavelength doesn't change, but the intensity decreases, and that's absorption. So the power of the wave, the intensity of the wave, is absorbed as it goes through a medium. And that's it. Those are our properties of waves. Alright, hope you got lots of notes and enjoy.